Bismillahirrahmanirrahim. In this video we'll learn about Karnaugh map or K-map. Now, the Karnaugh map is a method that provides simple and straightforward procedure for minimizing Boolean functions. So let's start with the two variable K-map. Now for two variables we would require 2 raised to the power 2 4 boxes. Actually the general formula is this. So if we have 3 variables, then it will be 2 raised to the power 3, that is 8 boxes. If you have 4 variables, then 2 raised to the power 4, 16 boxes. So here, since there are 2 variables, so we'll require 4 boxes. Now before we plot on the box, we should just have the truth table in front of us. We know these are the various options for 2 variables. So these are the 4 boxes and the variables are x and y. So here we write x and on the right hand side we write y. We can also write the values here. So 0 and 1 for y and 0 and 1 for x. And what this means is that here we plot 0 0, so 0 0, so this value 0 0 is plotted here. This is 0 1, this is 1 0, and here 1 1. If we write the symbol for the minterms, this is M0, M1, M2, M3, then we can write the symbols also in the boxes. So by writing symbols, we get this. So M0 here, M0 is actually 0 0, so 0 0 was here, for that we writing M0. Similarly, M1 is actually 0 1, so 0 1 was here, so here we'll write M1. Same way M0, M1, M2 and M3. And the most comprehensive of all is this, encompasses everything. This is in terms of x dash, y dash, which is actually 0 0, x dash y, xy dash and xy. Also it is written in terms of minterms, M0, M1, M2, M3. And now this box is x1, so that is why it has given in a bracket that this is x, this value is x, where x is 1, and where y is 1, this is y, representing y. Okay, now let's plot. The question is plot the function xy or x dot y. So we go to the truth table and we know that x dot y is 1 only when both x and y are 1. That means we can put a 1 in the box which is M3. So if you remember, this is M3. So here we'll put symbol 1. So this is how we plot. Now let's plot another one. Now this is not AND, this is OR function, x or y. We'll again take help of the truth table. So for this truth table, now x or y, I'm sure you'll recall that it will be 1 when any of the variable is 1. So when y is 1, it is 1. When x is 1, it is 1. And when both are 1, it is 1. That means we'll have to put 3 ones in these 3 boxes, M1, M2, M3. So let's plot. So this is the box. And now we put 1 into M1 and then M2 and M3. So this is how you plot the functions. Okay. Now entering value in K-map and writing output expressions. The first question is for the function f x dash y plus xy, enter the value in the K-map and write the simplified output expression. So this is one expression, but with the benefit of K-map is that we can get a simplified expression. So let's see. Okay, now before we go into the K-map, just I wanted to show that you could have done it directly with the De Morgan's theorem. You can by putting the values. If you take y common from here, it will be x dash plus x, and x dash plus x from here is 1. So the answer is y. So this we could get from the De Morgan's theorem. But as the function becomes complicated, it becomes very difficult to solve like this, and that is the case when K-map becomes very useful. So let's see this in the K-map now. This is our function. Now we have written the truth table, and from here we have to put the value of function 1. So when will this be 1? When either this term is 1 or this term is 1. So x dash y is 1. Now x dash y means 0, 1. So 0, 1 is 1. And then xy is 1, that means 1, 1. So 1, 1 is 1. That means we can put in the box marked M1 and M3 the value of 1. So at M1 we put 1 and at M3 we put 1. And now comes the best part, that we can make these two a pair. So this is a pair. Now if we look from the left hand side, there's nothing common in between the two. Here it is x is 1, here it is x is 0, so nothing common. But here you can see, if you look from the top, then you can see that in this case y is 1 here and y is also 1 here. Therefore, we'll write that this is equal to y. So our answer is f is equal to y. Now you can see this was the function which by K method we have found its value to be y, which is actually what we had got by solving the De Morgan's theorem. Let's see a couple of more examples. Now let's see the 3 variable K map. So we need 8 boxes. So we select the boxes like this. Then we take help of the truth table and minterms, you remember. Now the important point to remember in case of a more than 2 is that the sequence is disturbed here. M0, M1, then it should have been M2, but it is disturbed. It is M2 is on the right, and then at the middle place on the third column is opposite. So M0, M1, M2, then M3. Similarly here M4, M5, M6, and then M7. So this is very important. Most of the time student makes this mistake and the whole answer becomes wrong. So keep this point in mind. And as in case of a 2 variable, here also we have all these in terms of x dash, y dash, z dash, or in terms of the minterm values M0, M1, M2, M3, and in terms of 0, 0, 0, 1, 1, 1, 1, 0, etc. Okay, now let me explain some of the methods of simplification. If you have two which can be shared, then this we will share like this. These two can also be shared. That is the effort of minimizing, that as much as you can share, but it has to be either 2 or 4 or 8. Now here you see this one is here and this is on the extreme right, but it is just like folding a paper. If you fold this paper, so if you fold this one, then these two becomes connected and therefore these two can be shared also. Here are 4 that can be shared. These 4 can also be shared. And these 4, 2 from here and 2 from the right hand side by folding. So these can also be shared. If we have 3 like this, then still we have to make pairs. So this is one pair, and instead of leaving this alone, it is better that we share this with the other one, although it is already being shared here. So this will also help in minimizing. And then the best is that if you can share all of them, that is the best option or best. Okay, now let's